गुड मॉर्निंग स्टूडेंट। आज हम नेक्स्ट टॉपिक पढ़ेंगे कम्यूटेटिव ऑपरेटर। सो कम्यूटेटिव प्रॉपर्टी ऑफ ऑपरेटर क्या है? तो इसमें क्या है कि अगर हमारे पास दिस इज ए एंड बी टू ऑपरेटर है विच इज ऑपरेटिंग ऑन अ फंक्शन and this is the B operator and this A operator and the function not equal to B operator and A operator and function, then it is called here, this is the property of commutative operator. So let's see कि अगर इसको हम एग्जाम्पल के साथ देख लेते हैं कि whether it is feasible or not. तो let's see here that अगर यहाँ पे A operator है is equal to x here and the B operator is equal to d divided by dx and जो फंक्शन है this function that is equal to x raised to power 4, there is function की वैल्यू जो है that is x raised to power 4 है। so therefore अगर हम इसको इसके ऊपर ब्रेक करके देखें तो यहाँ पे देखिए this is A operator, this is B operator and the function will be equal to, this is the A operator is x here, B operator है d divided by dx and f क्या है x raised to power 4. So therefore this is the simple differentiation here. So it will be x square 4x3. So therefore we get 4x raised to power 5, which is the A operator and B operator and the function. दूसरी टर्म ये हमारे पास रहती है, अब हम इसको सिंप्लीफाई कर लेंगे। सो देयरफॉर दिस इज B ऑपरेटर, A ऑपरेटर एंड F। B ऑपरेटर की वैल्यू जो है दैट इज d by dx एंड हियर इज द x स्क्वायर इज देयर। सो एंड फंक्शन क्या है x raised to power 4. So therefore this is the d by dx x raised to power 6. So that will be the 6x to 5. So this is the B operator and A operator and F. That means to say that these two operators do not commute with each other. So we can say that these two operators do not commute with each other. So this is the one of the property of the commutative operator. And साथ में ही है कि अगर commute कर सकते हैं तो therefore what is that example? That is, this is A operator and this B operator and the function. This is equal to this B operator, then A operator and the function. If they are equal to each other, and then what is the condition in that? So therefore, here is this. So यहाँ पे A operator जो है वो d by dx है, and this B operator is the d divided by dx square है d. And the function है that is equal to is sin x. So we will operate this operator on this function and after that on this and see that what are the result. To see here that कि अगर यहाँ पे this is the A operator, this is the B operator and the function will be equal to, this is the d divided by dx and this is the d divided by d square and dx square divided by dx square is the sin x. So if we solve it step by step, so we will get here first is the differentiation of sin is cos, then cos की differentiation is the minus sin. So therefore d by dx is the minus sin x is there, and after that the differentiation of this is the minus cos x is there. So therefore this A operator and this B operator and the function is equal to minus cos x है। अब इसके बाद जो है दूसरी वैल्यू रहती है this B operator and A operator and F. तो therefore that will be equal to this B operator, this A operator and F will be equal to B operator जो है यहाँ पे is equal to है d divided by dx square and here is the d by dx and here is the sin x. So therefore this will give a d by dx here and sine जो है that will change into the cos x, and after that it is again followed by the double differentiation. So this is equal to cos is equal to change into sine x minus, and then change into the minus cos x. So after the double differentiation, that is B operator, this A operator and F. So finally we will see that these two operator, that is A operator, this one जो इसका result आया था, this one and this one. So this is result of that. That means to say A operator and B operator जो है वो commute करते हैं. So this is all about of the commutative operator. After that is the commutator, that is commute operator था, इसमें हम है commutator operator जो है, that is what है commutator. What is condition in that? This is the A operator, B operator in the square bracket is equal to this A operator, B operator, and this B operator and A operator is equal to 0. So this is the condition for the commutative operator. And इसके बाद जो है next आ जाता है linear operator. What is the linear operator? In that case, if we have this two operators there, that is this is A operator is there, we have the function f and g. तो अगर पहले दोनों के फंक्शन को ऐड कर लिया जाए, adding of the function, then operator of this operator give the same result as this is A operator f and A operator and g. So in that we can add here, so therefore then operator of the A, so which give the same result as the A operator f and A operator g is there. A operator function and A operator is the g function is there. So that's all from this. This is all part of the linear operator. इसके बाद next आ जाता है Laplacian operator क्या है? Laplacian operator है, it is denoted by this del square, which is equal to curly square divided by curly x square, curly square divided by curly y square, and curly square divided by curly z square. तो in that case हम ये श्रोडिंगर इक्वेशन में पढ़ते हैं, तो you know that this is curly square divided by curly x square psi, and curly square psi divided by curly y square, and curly square psi divided by curly z square plus 8 pi square m divided by x square, this e minus v, and the psi is equal to 0. So this was the Schrodinger equation into the three different coordinates. अगर हम इसको इसमें से psi कॉमन निकाल लें, तो इसमें भी curly square divided by curly y square and curly square divided by curly z square, and this is the psi plus 8 pi square m divided by x square, this is the e minus v, and the psi is equal to 0. So this is called here the Laplacian operator. Del square psi plus 8 pi square m divided by x square, this is the e minus v, and the psi is equal to 0, which is called here the Laplacian operator. So this is the Laplacian operator. इसके बाद एक next आ जाता है what is Hamiltonian operator. So let's see what is that. Hamiltonian operator. अगर हम Hamiltonian operator की बात करें, तो let's see we have a system like यानी इलेक्ट्रॉन की बात करें तो उसकी जो सिस्टम की एनर्जी है दैट इज व्हिच इज इक्वल टू हियर kinetic energy and potential energy. So this is total energy of the system is equal to kinetic energy plus the potential energy of that system. And you know that this is kinetic energy which is equal to E minus V is like this way. So अगर हम यहाँ पे m से मल्टीप्लाई करें और m से डिवाइड तो इट विल बिकम दिस वन. दिस इज E minus V is like this way. And you know that this is m and V को हम क्या कहते हैं? मोमेंटम. So therefore this is 1 by 2 and this is the P square and here is E minus V and which is called as the potential energy of the system. And यहाँ पे जो potential energy है this is E minus V. So can we write here this is like this way. This is P is called the momentum. If we discuss this momentum into three different directions, this Px, then Py, and then Pz. So therefore it is 1 by 2. Here is m. This is the Px, Py, and Pz square. और अगर ये पोटेंशियल एनर्जी को इस तरफ ले आए तो दैट इट विल बी द प्लस इक्वल टू E. So we will get this one. This is 1 by 2m. This is the Px square, this Py square, and Pz square. That is the momentum into the three different coordinates. And if this is equation number 1, you know that कि अभी हमने श्रोडिंगर इक्वेशन पढ़ी थी. तो जो श्रोडिंगर इक्वेशन है that is minus h square divided by 8 pi square m. This is curly square divided by curly y square x square, curly square divided by curly y square and curly square divided by curly z square plus v psi is equal to here the E psi. So this is the Schrödinger equation जो है उसका सॉल्यूशन जो हमने पहले लेक्चर में डिस्कस कर चुके हैं. अगर हम इन दोनों इक्वेशन को कंपेयर करें एंड इग्नोरिंग द साइन तो लेट्स सी कि इसको हम सिंपलीफाई कैसे करेंगे. सो हियर इज द दिस इज 1 by 2m, दिस इज 1 by 2m and the Px square will be equal to this is minus x square 8 pi square m is here and curly square divided by curly x square है. तो let's see कि अगर हम this m के साथ ये m कैंसिल हो जाएगा तो therefore this Px square will be equal to minus x square divided by 4 pi square and curly square divided by curly x square आ जाएगा. तो therefore Px किसके बराबर आएगा? minus h divided by 2 pi के बराबर आएगा and curly divided by curly x के बराबर. So let's see कि यहाँ पे ये Px की वैल्यू निकली है जिसको हम कहते हैं मोमेंटम ऑपरेटर. ये Px क्या है? मोमेंटम ऑपरेटर. तो therefore this Px will be equal to h divided by 2 pi iota and curly divided by curly x. So this is the momentum operator into the x डायरेक्शन की जो सॉल्यूशन है. अब ये हमने अगर एक सॉल्यूशन फाइंड आउट किया है इसी तरह से हम यहाँ पे Py का कंपैरिजन इसके साथ कर लेंगे. सो देयरफॉर इट विल बी नाउ हियर 1 by 2m and here is Py square and which is equal to minus x square and 8 pi square m and is curly square divided by curly y square. So this and to and this cancel, then again this Py will be equal to minus x square 8 pi square and here is curly square divided by curly y square. And अगर हम इसका सिंपल ले तो इट विल बी द माइनस एच एंड इट विल बी द here is the 4 pi it will be the 2 pi and curly divided by curly y and in that case इसको हम मोमेंटम ऑपरेटर कहेंगे. So this is py which is equal to h divided by 2 pi iota and curly divided by curly y. So this is momentum operator. हम इसको कह सकते हैं कि this is the momentum operator along the x, ये है momentum operator along the y. अब इसके बाद जो है z डायरेक्शन में रह जाता है, तो that is what here that is in that we have this 1 by 2m and here is pz square that will be equal to minus h square divided by 8 pi square m and here is curly divided by curly z square. So this m to this m cancel, so we are left with this that is pz square is equal to minus h square divided by 4 pi square curly square divided by curly z square, and therefore this pz will be equal to minus h divided by 2 pi curly divided by curly z, and उसको हम iota से इस तरह से लिख सकते हैं कि this pz is equal to minus this is h divided by 2 pi iota curly divided by curly z. So this is called as the Hamiltonian operator जो है, और इसके साथ हम मोमेंटम ऑपरेटर को भी सॉल्व कर सकते हैं. तो दैट मीन टू से कि ये सारी जो डिस्कशन है दिस इज टोटल इज इक्वल टू एच साई होता है, जिसको हम पहले श्रोडिंगर इक्वेशन में भी सॉल्व कर चुके हैं. So this is our mode of the Hamiltonian operator. एंड नेक्स्ट इसकी कुछ डिस्कशंस जो है न्यूमेरिकल की कर रखी हैं. सो कम्यूटेटर ऑपरेटर की, तो दैट इज इफ वी हैव x एंड द dx, so question is that evaluate the expression for this operator as a commutator. So therefore it is written as this is x d by dx minus d by dx and here is x. लेकिन इसको सॉल्व करने से पहले हमें कोई फंक्शन अज्यूम करना पड़ेगा जो इस ऑपरेटर के ऊपर ऑपरेट हो. तो लेट्स सी that psi is a function. Psi is a function. So therefore we will write here this one. So therefore this is x. It is the d psi divided by dx. ये इसके साथ यहाँ मल्टीप्लाई है. This is the d by dx and here is the x psi. So therefore we will get d psi divided by dx and where the two functions are here. So therefore this is the first function as such, and the differentiation of psi d psi upon dx minus here is the psi as such and the differentiation of x is 1. So this is minus and this is plus, so we are left with minus psi. And अगर यहाँ पे ये psi function लिया था, so therefore this x d by dx and this is operator, this is the psi, this psi to psi cancel, therefore this s x divided by dx will be equal to the minus 1. So this is called the commutative operator. And इसके बाद जो है एक और डिस्कशन भी है x स्क्वायर d स्क्वायर डिवाइडेड बाय dx स्क्वायर. This is called the commutative operator. And the question is ये अक्सर पेपर में आता है कि evaluate the expression for this. So therefore in that case पहले हम psi एक फंक्शन लेंगे जो इस ऑपरेटर के ऊपर ऑपरेट होगा. So therefore it is written as this is d psi upon d x square d square divided by dx square and This is the size function which is equal to x square d square divided by dx square. Here is d square divided by dx square and x square and the sign. So यहाँ पे this is the psi is the function. अब ये psi function जो है वो इसके साथ रिलेट होगा, इसके साथ रिलेट होगा. तो let's see कि it will be the x square d psi divided by dx square and minus is the d square dx square and here is the x square and the psi is here. So this is the जो इसके साथ solution आएगी. अब इसके बाद हम इसको दोबारा से सिंप्लीफाई कर लेंगे. It will be x square d square psi divided by dx square and here is the double differentiation. So d by dx of that x square is as such and differentiation of psi is d psi upon dx. Then here is the psi as such and the differentiation of x square is the 2x. So this is up to that we have solved. अब इसके बाद जो है इसको कैसे सॉल्व करना है, that is here x square d square and dx square minus is here. तो अब ये भी टू फंक्शन है और ये भी टू फंक्शन है. तो लेट्स सी कि यहाँ पे माइनस साइन है. तो इट इज द फर्स्ट फंक्शन इज एज सच है माइ x square and differentiation of is the d psi and dx square and with the minus sign is here and it will be d psi divided by dx and differentiation of x के कितनी होगी 2x. So this will be here and after that is here plus जो है इसके साथ जो minus e है. So therefore it is the minus here. The 2 is जो 2 यहाँ पे लिख लेंगे and function जो है x as such and to the d psi upon dx and after that here is the minus 2 sine and differentiation of x is 1. So therefore this is plus and this is minus is cancelled. So we are left with this. We are left with here. This is the 2x d psi divided by dx minus 2x d psi divided by dx minus 2 psi. This will be equal to the minus 4x d psi divided by dx minus 2 psi and therefore it will be the minus 4x d divided by dx minus 2 and the psi. So this is the x square d square divided by dx square and this one. So this is the called cumulative operator and their expression. This is simple case of that.